The radius of convergence is derived from the interval of convergence, which shows a set of x values for which a series converges. In order to find the interval of convergence, we run the ratio test, which basically puts the next term divided by the previous term, and once we simplify that, we put that answer between the bounds of -1 and 1 and simplify until x is alone. We then find the distance between both endpoints and divide by 2 in order to find the radius. Here we have the sum of x to the n from n equals 1 to infinity, and once we apply the ratio test, we have x to the n plus 1 divided by x to the n. Simplified, this is x. We then put x between -1 and 1, and since x is already alone in the middle, we don't have to simplify anymore. The distance between -1 and 1 is 2, so we divide 2 by 2 to equal 1, and the radius of convergence equals 1. Next, we have a series that's a little bit more complicated. It's the sum of -1 to the n times the quantity of 4x plus 1 to the n from n equals 1 to infinity. After applying the ratio test, we have -1 to the n plus 1 times the quantity of 4x plus 1 to the n plus 1 divided by -1 to the n times the quantity of 4x plus 1 to the n. After simplifying, we can remove both terms from the denominator, -1 to the n and 4x plus 1 to the n, and cancel both exponents out in the numerator to leave just -1 times 4x plus 1. We then put -1 times 4x plus 1 between the bounds of -1 and 1, and once we cancel out the -1 in the middle, we have 1 is greater than 4x plus 1, which is greater than -1. Subtract 1 from both sides, we're left with 0 is greater than 4x, which is greater than -2. Then we divide by 4 to leave x alone, and we have 0 is greater than x, which is greater than -1/2. Since the distance between 0 and -1/2 is 1/2, we divide 1/2 by 2 to get 1/4, which is the radius of convergence for this series. You can apply the ratio test to any series in order to find the interval of convergence and then derive the radius of convergence. My name is Samantha Steppe, and I'm in Dr. Stornetta's Period 5 class. Thank you for listening.